In this video, we will talk about how to actually graph a rational function. Okay, so step one, we will first identify what we call our vertical asymptotes. And again, vertical asymptotes refer to the values of x that make the denominator or the bottom of your fraction equal to 0. So we'll take the bottom, set it equal to 0, and solve. In this case, because I have a quadratic, in order to solve a quadratic, I must try to factor it first. My factors will be x minus 8 times x plus 6, and then I will individually set each factor equal to 0 so that I can solve. So you'll notice this particular function is going to have two separate vertical asymptotes. X equals positive 8 and x is equal to negative 6. Okay, so then next you would determine whether or not you have a horizontal asymptote, and if so, what it is. So when I look at my particular function, the highest power of x on top is x squared. The highest power of x on bottom is also x squared. So we have equal powers. And when we have equal powers, we're going to look at the coefficients in front of those x's. So we have what's understood to be a 1 on top in front of your x squared term. And we also have what's understood to be a 1 on bottom. So 1 divided by 1 would give me a horizontal asymptote of simply y equals 1. Now, for the graph, with our vertical asymptotes, we typically show those with a dotted line. So there's x equals 8. And x is equal to negative 6. And then for my horizontal asymptote, y is equal to 1. Now, we'll get some test points, because mainly what we've got to do at this point, if we look over at this region on the left, you're either going to have a piece that's going here following your asymptotes or down here. So we have to figure out which of those two pieces you have. So we need a point in this region. So if we have x is equal to negative 6 here, then we have a point here of negative 7 that we could plug in, or negative 8, negative 9, negative 10, whatever, just plug it in. And the main thing we need to see is where that y value would actually be. So you can do your plugging in on a calculator if you want, or you can, do it by hand. I'll just show it by hand. So I'm plugging it into my original function up here. So let me move that so I can clearly see it. So a negative 7 squared would give me a 49. And then plus 5 times negative 7 would be negative 35. And then we have plus a 2. All right, then on bottom, again, negative 7 squared would be a 49. Minus 2 times negative 7 would give me a 14. And then we have minus a 48. So now if we go ahead and simplify that, 49 plus negative 35, that's going to leave me with 14. And then plus 2 would give me 16. And then on bottom, 49 plus 14 is going to give me 63, and 63 minus 48 would leave me with, what is that, 15? Okay, so 16 over 15. So that's bigger than 1, which would basically tell me the point is up here above that asymptote, and we know a graph has to follow the asymptote, so we would have a piece like that. Now, in between, you're going to want to do a couple of test points, because here are the things that could happen. You could get a U that's opening up like that. You could get a U opening down like this, or you could get an N that goes from down to up, or a backwards N that goes from down to up. So we need a couple of test points kind of near those asymptotes so that we can get a good idea of what is happening with this particular piece of the graph. So my asymptote's at -6. I'm going to go ahead and plug in -5. So -5 squared would be 25, plus 5 times -5 would be -25, plus 2. Okay, so that gives me a 2 on top. And then on bottom, -5 squared is 25, minus 2 times -5 would be plus 10, and then minus 48. We're going to get 35 minus 48. So bottom line is it's going to be negative. I don't even care about the value at this point, because that's telling me it's down here. So right now I know this piece of the graph is coming like that. And then I'll come over here to the right, and if this asymptote here is at 8, I'll plug in +7. And so 7 squared would be 49, plus 5 times 7 is 35, plus 2. So what is that, 70, 86. And then on bottom, 7 squared is 49, minus 2 times 7 is 14, and then minus 48. So let's see, 49 minus 14 leaves me with 35 minus 48. Well, bottom line is that's going to be negative as well. So we see that this piece is going to turn down just like that. And then finally, we need something over here to the right, because you're either going to get a piece that goes like this or a piece that goes like that. So if that asymptote is at x is equal to 8, then we can plug in something such as 9. 9 squared would give me 81, plus 5 times 9 is 45, plus 2, so that's a big positive number. On bottom, 9 squared is 81, minus 2 times 9 is 18, and then minus 48. That's positive, so I'm not even focused really now. I'm just trying to see if it's positive or bigger than 1. So in this case, let's say I do need to know that it is bigger than 1, not just positive. So let's see, 126 plus 2 would be 128 on top. And if I take 81 and I subtract 18, that gives me 63. And then I subtract another 48. Then I'm left with 15. So yeah, definitely bigger than 1. So this piece would go like this. And that is the graph of that rational function.